Okay, if we just have a quick look at this titration equation, we're going to have a look at the a reaction involving sodium hydroxide and hydrochloric acid, and it's going to produce sodium chloride and water. The reactants are in a 1-to-1 ratio, so it makes everything a lot easier to calculate. Now the first question is we need to work out the number of moles in solution of the sodium hydroxide. Now to calculate moles in solution, we use this equation. Moles in solution is equal to M times V over 1,000. The V is the volume, but the volume is always reported in cubic centimetres. M is the molarity, sometimes written down as concentration, but that is in decimetres cubed, moles per decimetre cubed. That's why we have to divide by 1,000. But anyway, we've got the moles in solution, M times V over 1,000. So in the titration, certainly the 1-to-1 titration we're going to look at now, we can just use this simple sort of idea that M1 times V1 over 1,000, which is just basically this, is equivalent to M2 times V2 over 1,000. And the M1 and the V1 are just basically either the acid or the alkali, and the M2 and the V2 is the acid or the alkali. So if we've used the acid here, calculated the number of moles of the acid in a 1-to-1 ratio, that should equal the number of moles of the alkali. So a really simple example here is if we've got a 0.1 molar solution and we use 25 cubic centimetres of it, that would be equivalent to using 12.5 of a 0.2 molar solution. So i.e. double the strength, you only need half the volume, or conversely, if you have half the strength or half the concentration, you need to use double the volume. Anyway, we're going to use this M times V over 1,000 to calculate the number of moles in solution. So in our question, we were told that we had 35 cubic centimetres of 0.1 molar NaOH, and that was equivalent to 25 cubic centimetres of our unknown molarity HCl. So you can work out the number of moles of the sodium hydroxide using the M times V over 1,000. So we've got the M and the V. So 0.1 times 35 divided by 1,000, and that would equal 0.0035. Because it's a 1-to-1 ratio, the number of moles, which we just worked out, of the sodium hydroxide is going to be equal to the number of moles of the hydrochloric acid. So the number of moles of hydrochloric acid is 0.0035 because it's the 1-to-1 ratio. So the 0.1 molar times 35 divided by 1,000. 1,000, we divided by 1,000 just to correct the figures because we got the volume in cubic centimetres but the molarity in decimetres cubed. So that would give us our number of moles. It's the same number of moles of HCl because it's a 1-to-1 ratio. And then we just basically rearrange our equation. So we've got our unknown molarity times 25 divided by 1,000 equals 0.035. We can make that easier for ourselves. We can get rid of the 1,000. So we need to times by 1,000. So we end up with, let's see, our unknown molarity times 25 equals 3.5. So you rearrange that. So if we rearrange that, we want to get rid of the 25 to leave the unknown on its own. So we divide by 25, they'll cancel out, but we have to divide by 25 on that side. So our unknown is 3.5 divided by 25. So 3.5 divided by 25 should be 0.14, and that's the concentration of our HCl. And if we look at it, let's see, if we go back up here, 0.14, that looks about right because we've got a stronger concentration. 0.14 is stronger than 0.1, so therefore we use less of it, 25 instead of 35.